Hello guys, welcome back to another problem set. Now in this problem set we're going to be looking at what? The peak height and the range. So in this question we are asked to find the peak height and the range arrow. So after we finish working out the problem, one should be able at the very minimum to understand what the peak height is and what the range is. Let me put this arrow over here. So, the question reads, a projectile is launched from off the top of a cliff with a velocity of 50 meters per second at an angle of 30 degrees above the horizontal as shown below. Find the peak height P and range R given that the projectile lands after 15 seconds. So we want to find the peak height P and the range R. The first thing we do in this case, notice that we are told that the projectile traveled from this point up to this point for 15 seconds. Now, we want to find first the peak height P using which equation of motion? S is equal to ut plus half at squared. And what we're going to do in this case is that we're going to start from this point and end at this point. Why start at this point? So that we encapsulate this entire distance or this entire height. So we're going to start from this point and end at this point. Now, notice that the vertical component of the velocity at this point is 0, which is what we're going to be using as our initial. But because this is 0, this is going to automatically vanish. Our initial vertical component of the velocity is 0, so we're going to utilize that in order to work out the displacement or the vertical height P from this point up to this point. Let's get into it. So we already know that the vertical component of the velocity starting from this point is 0, so we end up with something like this. S is equal to what? Half a t squared. Now, in order to utilize this equation, this is a squared. Now, in order to utilize this equation, we need the time. The time for what? The time, let's call this portion T1 and this T2. T1 is the time taken to move from this point up to this point, and T2 is the time taken to move from this point up to this point. This is the time we need. But we're given a time of 15 seconds. What is 15 seconds in this case? 15 seconds is T1 plus T2, but we only need T2. So what we're going to do is we're going to calculate T1 and subtract it from 15 so that we get our value of T2. T2 is what we require in this equation over here. This T is T2. But first let's calculate T1 and subtract it from 15 so that we're left with T2. I'm going to rub all of this off because of space. How do you calculate T1? We use our equation. V is equal to U plus AT. Remember, we're looking at this portion of the motion. So moving from this point to this point, we get that the final velocity, once we reach this point, the final vertical component of the velocity is 0. In this case, the initial vertical component of the velocity is 50 sine 30 degrees. But the final is 0. So we've got something like this. 50 sine 30 degrees plus, now again in this case we're assuming that the acceleration due to gravity is 9.81. So we've got our acceleration of what? Minus 9.81 times the time we're looking for, the time T1. Now I said minus 9.81 because this is what I chose. If I had chosen to make the acceleration due to gravity positive, this over here, the initial velocity would be negative. So in this case, the coordinate system I'm using is oriented in this way. So this is positive, this is negative, that is positive, that is negative. Because the acceleration due to gravity acts towards the center of the earth, which is down, this is negative. And because the initial vertical component of the velocity, in this case, is going up, this is positive. Positive. So that's what I'm doing here. So let's find our value for what? For T1. What is T1 in this case? This portion becomes a negative. So let's bring this part over to the other side. We get 9.81. T1 is equal to 50 sine 30 degrees. So we get T1 is equal to what? 50 sine 30 degrees. All over 9.81. So T1 over here is equal to 50 sine 30 degrees all over what? All over 9.81. This is the value for the time over here. But we want T2. So what we're going to do is subtract this from this 15 seconds in order to get what? In order to get our value for T2. So we're going to write it over here now. T2 is equal to what? Is equal to 15 minus what? Minus this over here. So it's minus 50 sine 30 degrees all over what? All over 9.81. So this is our value for T2. So now we've got it. We're now going to use it to calculate the what? The peak height. So remember that we're going to be utilizing the equation of motion. S is equal to ut plus half a t squared. But since I said we're going to be starting from this point up to this point, our initial velocity, the vertical component of the velocity at this point is 0. So this is out of the question. So I'm going to rub this off and write it thus. Half a t squared. So this is what we're working with here. So we've got half. What is the acceleration due to gravity? It's minus 9.81. What is t squared? Now, t squared is basically this squared minus 50 sine 30 degrees all over 9.81. So S is equal to half times minus 9.81 times 15 minus 50 sine 30 degrees over 9.81 squared. Now, if you punch this on your calculator, now let me rub this now. If you punch this on your calculator, I'm not going to simplify it for you. You can simply punch it directly as it is on the calculator and get your value for S. You'll find that your value for S is equal to minus 760, 480 and so forth. And expressing this in three significant figures, we've got minus 760. The displacement is negative since we're going down. So we've got to three significant figures, minus 760 meters to three significant figures. So what is our peak height? Now our peak height is not minus 760 meters. our peak height, we now remove the negative. We want the height. The height is basically an absolute value. So the peak height, P, is equal to what? The peak height is equal to 760 meters to 3 significant figures. I'm just putting it to 3 significant figures, but it all depends on the number of significant figures or decimal places they require you to put your answer in. So in this case, we find the peak height to be what? To be 760 meters. Now we want to find the range. Now, finding the range is very, very simple. I'm going to rub this off. So keep in mind, the peak height is 760 meters to 3 significant figures. Now we want to find the range. Remember, I mentioned in the previous videos that the horizontal component of the velocity is constant to such an extent that you can simply use the speed is equals to distance over time formula, which of course comes from S is equals to ut plus half at squared, where the acceleration is 0. So this vanishes, and you're left with this. This and this are exactly the same thing. In this case, S is our displacement, or we can simply call it the distance. And U, our initial velocity, we can simply label it as S now for the speed. So this and this are simply the same thing, with D having been made the subject of the formula in this case. So we're using our speed is equal to distance over time formula here. What is our speed? Our speed is the horizontal component of the velocity in this case. But let's first make D the subject of the formula, since that is what we're looking for. D is the range. D is equal to what? The speed times the time. Now what is the speed? The speed is equals to V cos 30 degrees. So we've got V cos 30 degrees multiplied by what? Multiplied by the time. But which time? Is it T1 or is it T2? It's neither T1 or T2, but it's the combination of the two. It's T1 plus T2. We do not need to calculate that. We're already given T1 plus T2 over here. So it's 50 cos 30 degrees multiplied by 50. What do we get? We get something like 649.519 and so forth. And if we put this again to 3 significant figures, we get 650 meters to what? To 3 significant figures. So this is our range R. Simple, right? Nothing special about the range. So that is how we calculate the peak height P, and that is how we calculate the range R. Now we're going to be looking at more problem sets. This I would basically term or phrase as a beginner kind of problem set. But in the future we're going to be looking at more sophisticated or more complex problem sets pertaining to peak height and the range and other topics we've covered thus far. That is the velocity and the time of flight. But that is in the future, and hopefully, I'm not guaranteeing it, hopefully, maybe I might prepare the problems based on demand. Like if people request them in the comment section and so forth, I might make the problem sets. But hopefully we're going to be looking at more complex problem sets as compared to this, but upon request most likely. So this is how you calculate the peak height and the range. Thank you so much, ladies and gentlemen. Please leave a like, subscribe, and comment if you enjoyed the video. See you in the next one. Thank you.